Hello students, till now we have covered the topic phenomena of reflection. Today we'll go with the topic spherical mirror. As it's clear by the term, spherical mirror means such mirror whose reflecting surface is spherical in shape. These are of two types, concave mirror and convex mirror. In concave mirror, the outward surface is polished and the inside surface or the inward surface is reflecting surface. On the other hand, in convex mirror, the inward surface is polished and the outward surface, this plain curved line outward, acts as a reflecting surface. Concave mirror is called converging mirror because the light rays fall on its surface after reflection, converge on a point or meet on a point, and that's why this concave mirror is called converging mirror. In convex mirror, it has a tendency to diverge the light ray, those who are falling on its surface, and that's why it is called diverging mirror. Here are some important terms related to spherical mirror. The first term is center of curvature. These two spherical surfaces or mirrors are actually the part of a hollow sphere, and the center of that hollow sphere of which the mirror is considered to be a part is called center of curvature. Pole, the center of spherical mirror that we have taken as a part of hollow sphere, the center of that spherical mirror is called pole. Aperture, the effective diameter or the effective length of a spherical mirror is called aperture. Radius of curvature, the distance between center of curvature and pole is called radius of curvature, denoted by R. Principal axis, the straight line which is joining the center of curvature and pole is called principal axis. The next is focus. For that, see this diagram. The light ray parallel to principal axis after reflection pass through a point, and that point is called focus. In convex mirror, these light rays after reflection do not pass actually from the focus. They appear to pass from a point, and that point is called focus or principal focus. Focal length, the distance between focus point or focus and the pole is called focal length, denoted by small f. Here in the same diagram, I have denoted all the length related term: aperture, focal length, radius of curvature and principal axis. Here a very important relation between radius of curvature and focal length, that the radius of curvature is always double of focal length. There are some rules for making ray diagram related to spherical mirror. The first rule is, when a light ray coming parallel to the principal axis, then after reflection from the surface, this light ray will pass through the focus, and here it will appear to pass through the focus. The second point is just opposite of the first point. When a light ray is coming from the focus to this reflecting surface of the mirror, then after reflection, this light ray will emerge to parallel of the principal axis, and same here in the convex mirror. The third point is about center of curvature. When a light ray coming to the center of curvature, then after reflection, it will not showing any deflection. It will go back along the same path. It happens because in this case, the incident ray is actually coming on the normal of the reflection ray. And due to this, because it is not forming any angle through the normal, and that's why there will be no deflection in the path of the light ray. And the fourth point is about when a ray incident to the pole making an angle considering angle I, then after the reflection it will form angle R, and the angle I will be equal to angle R, and that is the first law of refraction. Same in the case of convex mirror, it will follow the first law of reflection. We have discussed the rules for image formation. Now we will discuss image formation through concave mirror. There are 6 cases for concave mirror. The first case is when the object is kept at infinity. Infinity means we don't know the exact point where the object is kept. A light ray is coming from the object from infinity, which is parallel to the principal axis. Then after reflection, it will pass through the focus according to the rule. And another light ray is also coming parallel to the principal axis. Then after reflection, it will pass through the focus. Thus we get our image on focus at F. The position of the image will be at F. It is absolutely a real image because it is forming in front of the mirror and these light rays are meeting actually. That's why it is real image, point sized image or diminished image, and it is inverted image. The second case is when the object is kept between C and F. C, center of curvature, and F, focus. I have written C as 2F here because the radius of curvature is double of focus. So we can write C or 2F equally. So here is the object between F and 2F or F and C. A light ray is coming from the object which is parallel to the principal axis. After reflection, it will pass through the focus. And another light ray is coming from the object which is passing through the focus. Then, after reflection, it will be parallel to the principal axis. Thus, we got our cross point and we get the position of the image which is beyond 2F. 2F is here and the image is formed beyond 2F. It is absolutely real image because it is forming in front of the mirror, larger size than the object, and it is inverted. In the third case, when the object is kept beyond C. Now we are keeping the object beyond C. A light ray is coming from the object parallel to the principal axis. After reflection, it will pass through the focus. Then another light ray is coming from the object passing through the center of curvature or 2F. Then, after reflection, it will go back into the same path according to the rule. Then we get the position of the image here at that cross point which is between F and 2F. It is real image, smaller than the size of the object and inverted. The fourth case is when the object is kept at C or at 2F. So, now a light ray is coming from the object parallel to the principal axis. Then after reflection, it will pass through the focus. And another light ray is coming from the object passing through the focus. Then after reflection, it will be parallel to the principal axis. And we get our image here and the position of this image at on point C or at 2F. The same position where the object is kept. It is of same size of the object, real and inverted. The fifth case is when the object is kept at F, focus. Focus, object, a light ray is coming parallel to the principal axis. Then after reflection, it will pass through the focus. And another light ray is coming from this object and incident on pole. Then after reflection, it will make a same angle with principal axis and will reflect like this. Thus we get these two light rays are parallel to each other. So we can say that they will meet somewhere at infinity. So our image is formed at infinity and of larger size, real because it will form in front of the mirror, and inverted because real image are always inverted and virtual image are always erect image. The sixth case is very special case and very unique case, unlikely these fifth. When the object is kept between F and pole, object, light ray parallel to the principal axis, after reflection will pass through the focus, and another light ray will come on pole, then after reflection making the same angle, it will be reflected. Now we can see here these two light rays are not parallel, so they will not meet even at infinity. They'll meet somewhere behind the mirror or appear to meet somewhere behind the mirror, and thus we get our position of the image behind the mirror. Because here the image is formed behind the mirror, that's why it is called virtual image. And I told you that virtual image are always erect image and it is larger size than the object. Image formation of the convex mirror. There are two cases. When the object is kept at infinity. From infinity, light rays are coming, and due to its diverging nature, these light rays are diverged. These diverged rays appear to meet on a point, that is focus. Thus, the image is forming at focus. Because it is forming behind the mirror, that's why it is virtual image, point size or diminished image, and because it's virtual image and virtual images are always erect image. When the object is kept between pole and infinity, you keep your object anywhere in this case, I mean at 2f, beyond 2f, between f and 2f, you will get the same result. So I have kept my object here, a light ray is coming parallel to principal axis, then after reflection, it will diverge due to the diverging nature of convex mirror, and it will appear to pass through the focus behind the mirror. And another light ray is coming from this object and it is coming from the center of curvature, so that's why it will go back along the same path according to the rule. Thus we get our position of the image, which is between F and P, focus and pole. It is diminished or very small size than the object, erect image due to its virtuality nature. So thus we have discussed all the cases of concave mirror and convex mirror. Your assignment is that you prepare a table in which it is written object, position of the image and nature of the image.